All right, so now we're moving on to compound inequalities. So compound inequalities just have two symbols, which means when we graph them, there will be two dots. So what you notice, or what you should notice from the above problems, is like I said, there's one symbol in the middle here, and now there are two. All right, but we narrow our vision in on the middle of the graph. Why? Because that's where X is. So you're always sort of focusing on this middle section, and you're saying to yourself, self, what's X with? 3 and 2. And then we undo, just like we always did. So the first thing we're going to undo is the number that's always behind the X. So how do we undo a 2 and make it disappear? I subtract 2. But as I mentioned in class, what you do to the middle, you now do to the outsides. There are two outsides because there are two symbols there. So whatever I wrote here in the middle, I'm going to do that to here and to here. 11 minus 2, remember in subtraction, we don't change the symbols. 11 minus 2 is 9, negative 4 minus 2 is 6. The 2's in the middle produced a 0, so all that's left over is 3x. And then, same exact set of questions. What's X with? 3. How are they connected? Multiplication, which we undo by division. So we're going to divide by 3, and what you do to the middle, you do to the outsides. 9 divided by 3 is 3. Negative 6 divided by 3 is negative 2. 3 divided by 3 is 1, which leaves us 1x in the middle. So I can just write that as a regular old x because that's 1x. And since we divided by a positive number, the symbols face the same way. So remember, the symbols only switch when the number that you are dividing by, this number that I've highlighted, is negative. It doesn't matter what's on top. It has nothing to do with these numbers. It has everything to do with these. If this number were negative, that's when I would flip the symbol. So since I'm dividing by a positive 3, let me get rid of all those, a positive 3, the symbols stayed the same. And from here, we graph it, 2 dots, one at negative 2, one at 3. Please make sure that you don't do one of these weird things, and don't laugh because kids do this all the time. They somehow flip the order. Okay, so just keep that in mind. So negative 2 has an open dot. 3 has an open dot. If I switched this symbol, then 3 would have a closed dot. Since your shading is in the, since your X is in between negative 2 and 3, it only makes sense to shade in the middle. And that's because your shaded section has to be less than 3. So numbers that are less than 3 are found over here. And at the same time, those numbers are also bigger than negative 2. So numbers that are bigger than negative 2 are over here, which is how they end up getting trapped kind of in the middle. But again, it looks just like the statement. So again, if somebody asks you to write the statement, they might say something like 15 and 19, and the shading might be something like this. And you would write that inequality statement as 15, 19, here's your X for the shaded region. And if you look at 19, the shaded section is smaller than the number 19. So that's the way that you write the symbol. And whatever symbol you write here, it has to match the same direction. Otherwise, it doesn't make sense. And oopsie, I added a line, which I shouldn't have, because this dot is open. So, same kind of thing. Just in a different order, I suppose. So the only other difference between this problem and this one is basically you've got one inequality solved at the same time with two symbols and two totally separate inequalities. And so when you've got the word or, you're literally just solving them as if the other one doesn't exist. So scratch this one out, pretend it doesn't exist temporarily, and just focus your attention on the first one. What's X with? How are they connected? How do we undo it? The same set of questions I've been asking you forever. First, we're going to undo subtraction with addition. Addition does not change the symbol. 5 and 5 is 10. The negative 5 and 5 makes a 0. X is with a 2 connected by multiplication, which I undo by division. We divide it by a positive number, so the symbol stays the same. There's your statement. I'm not going to graph it quite yet because some kids will put a 5 over here, and the number over here might be like negative 3, and then they put negative 3 over here, and that's how that weird stuff of the numbers getting flipped happens. So before I graph it, I'm going to solve the other one. Okay, so now put this one out of your mind. They have nothing to do with each other. Two totally separate things. What's X with? How are they connected? How do we undo it? Undo the first 2 by subtracting 2. watch your signs here. Negative 10 minus 2 is negative 12. Subtraction does not change the symbol. The 2's produce a 0, so all that's left is 3x. What's x with? How are they connected? How do we undo it? Divide both sides by 3. I'm dividing by a positive number, so the symbol stays the same. 3 divided by 3 is 1, but I don't need to write it. Negative 12 divided by 3 is negative 4. And now I'm going to put those numbers on the number line. So see, negative 4 is over here. I'm glad I didn't plot that earlier. 5 is here. Both have open dots because the symbols are have that line underneath. And this is saying x's are bigger than 5. Those numbers are over here. This says negative 4 is bigger than your number. If the negative 4 is bigger than your number, then your number must be smaller. And smaller numbers go to the left. And if that confuses you, you can very clearly see that when you've got x in the middle, you're shading in the middle. When you've got the word or, the sections that you're shading don't live in the middle here. They live on the outsides. Okay? Hopefully that clears things up.